Weather by Seymour Simon. It's cloudy today. It's also sunny, rainy, and snowy, hot and cold, calm and windy, dry and damp. Each of these descriptions of weather is true every day of the year, someplace in the world. We live in the atmosphere, the enormous ocean of air that surrounds Earth. Weather is what's happening at the bottom of the atmosphere, mostly in a layer 7.5 miles thick called the troposphere. Tropo comes from a Greek word meaning change. Above the troposphere, another layer called stratosphere extends up about 30 miles. Strato comes from the Greek word meaning covering. Living in the troposphere, we feel the weather in the temperature of the air and the wetness of the rain. We see the weather in the puffy clouds and the white snow. We even hear the weather in the clatter of hail against the roof and the distant rumble of thunder. Earth's weather is driven by the intense heat of the sun. The sun's energy travels through space in a form of visible light waves and in invisible ultraviolet and infrared waves. About 1/3 of the energy reaching the Earth's atmosphere is reflected back into space. The remaining 2/3 is absorbed during a process called insolation, from incoming solar and radiation. The atmosphere lets sunlight pass through. Sunlight heats the ground, which in turn warms the air near the surface. But the atmosphere prevents most of the heat from escaping into space. This is called the greenhouse effect, because the glass windows in a greenhouse trap heat in the same way. Insolation and greenhouse effect strike a balance and make our planet livable. If Earth's average temperature were to drop by a few degrees, the ice would return and glaciers would cover North America and Europe. If the temperatures were to increase by a few degrees, the polar ice caps would melt and the oceans would flood low-lying coastal lands. The sun doesn't warm the Earth evenly. At the equator, where the sun's rays are most direct, insolation is several times greater than at either of the poles, where the sun's rays come in at a slant. Most of the Earth's hot spots are located near the equator, and most of the cold spots are in the Arctic or Antarctic. The unequal heating of the Earth sets the atmosphere in motion. Air near the equator is heated, becomes lighter, and rises. At the poles, the colder air becomes heavier and settles downward. Warm equatorial air moves poleward, while cold polar air moves towards the equator. The constant change of warm and cold air between the equator and the poles is one key to the giant atmosphere pattern that makes up the weather.